Okay, some solved problems for Chapter 1, starting with some basic unit conversion. Essentially, we have a really nice car with 327 cubic inch engine, so let's go ahead and write that guy down, 327 inches, and this is not just inches, but inches cubed, very important. And we want to express the displacement in liters, knowing that 1 liter is 1,000 cubic centimeters, and knowing that 1 inch is 2.54 centimeters. So the first thing we want to do is we want to get rid of inches. So we want to essentially divide this guy by inches, and we're going to put centimeters right up on top. And we know that 1 inch is 2.54 centimeters. So here we have inches cubed, and here we have inches. So we can't just say, okay, these guys are going to cancel out. We actually need to say, okay, it's going to be inches cubed, it's going to go to centimeters cubed. So we have to make sure we cube this guy. Now we have centimeters cubed up on top. We want to get rid of that. We know that centimeters cubed, we want to put this in terms of liters. We know that 1 liter is 1,000 centimeters cubed. And let's just explicitly cancel our units. So here we have inches cubed, canceling out right there. Here we have centimeters cubed, canceling out right there. So what we're going to be left with is something in terms of liters. And if you go ahead and you do all the math, that's going to be 5.36 liters. Problem number 10, some more unit conversion. So we have three parts of the problem. Part A, we're going to convert 60 miles per hour into feet per second. So let's go ahead and say, okay, we have 60 miles per hour. And let's go ahead and get rid of the hours first. To do that, we want to put hours up on top, and we want to convert that into seconds. And we know that 1 hour is 3,600 seconds. Now let's go ahead and do miles into feet. We want to get rid of miles, so we're going to put that down here. Let's put feet right up here, and we're going to put 50 to 80 feet in 1 mile. Now let's go ahead and just cancel these units out. Let's get rid of miles right there. Let's get rid of hours. You can kind of see what we're going to be left with is going to be feet per second. Go ahead and pack that into your calculator, and you're going to come out with roughly 88 feet per second. For part B, we're going to convert feet per second squared into a more conventional meter per second squared. So 32 feet per second squared. And what we want to do is we want to get rid of feet. So let's go ahead and put feet right there, and let's put centimeters right up on top. We know that 1 foot is 30.48 centimeters, and we're going to also say, well, we don't want it in centimeters per second squared, we want it in meters per second squared. So let's go ahead and convert meters into centimeters. We know that in 1 meter there's 100 centimeters, so let's cancel out feet. Second squared is going to stay the same. Let's cancel out centimeters, and go ahead and you type all this in, and it's going to come out to a very familiar number, 9.8 meters per second squared. Lastly, part C, we want to convert grams per cubic centimeters to kilograms per cubic meters. So go ahead and write this guy out, grams per centimeters cubed. And what we want to do is we want to get rid of the meters and put centimeters up on top. 1 meter is 100 centimeters. Now we're talking about centimeters cubed right here, and that's not going to cancel out unless we go ahead and say I'm going to cube this entire quantity. Now we want to get rid of grams and convert that to kilograms, so we want to get rid of grams, put kilograms right up on top. We know 1 kilogram is 1,000 grams. Go ahead and explicitly cancel our units out. Centimeters cubed, grams, and what we're left with is meters cubed down on the bottom here, kilograms on top. So that's going to be 10 to the third kilograms per cubic meter. And now a little bit of practice with vector addition with problem number 27. Essentially we have a truck that's going to go 2.6 miles north, 4 kilometers east, and 3.1 kilometers at an angle of 45 degrees. And we're looking for the magnitude and direction of the resultant displacement, where the resultant displacement is going to be a vector. It's going to start at the start and finish at the stop. So kind of what we're looking for is that vector r. And we'd say, okay, well, r simply is going to be equal to a plus b plus c, but we can't just go ahead and add up 2.6 plus 4 plus 3.1 because there's some directions associated with these guys. So what we have to do is we have to say, okay, we're going to add their x components and their y components separately. So I'm going to just kind of define, kind of my standard xy. It's going to be my positive x direction. It's going to be my positive y direction. And I'll call this vector A, I'm going to call this vector B, and I'm going to call this vector right here C. So let's talk about components here. Vector A, all of the direction is along the y-axis, so there's going to be 0 kilometers traveled in the x direction. There's going to be 2.6 kilometers traveled in the positive y direction. Let's take a look at B right here. All of the motion is in the x direction, and so we're going to say 4 kilometers, and I'll explicitly note this is in the positive direction. I'm going to have 0 kilometers right here. Now, vector C, it's got some in the x, it goes this way, and some in the y, some that way. So I'm going to say, okay, this is going to be the x component. Right there is going to be the y component. Now, take a look at this guy. This is actually a triangle. Here we have 3.1 kilometers. That's going to be the hypotenuse. This is going to be the angle right there. So this is going to be the opposite side, and that's going to be the adjacent side. Remember our old friend SOHCAHTOA? So we would say, sine of 45 is going to be equal to the opposite side, cy, divided by the hypotenuse, 3.1. So we can say, okay, well, cy simply has to be 3.1 sine of 45. Similarly, you convince yourself that cx needs to be 3.1 cosine of 45. Go ahead and you type all that in. It's going to be 2.19 kilometers in the x and 2.19 kilometers in the y. Now we say, okay, we're going to add up all the x components over here. We're going to add up all the y components, and that's going to give me my resultant vector in the x, and that's going to give me my resultant vector in the y. So it's going to be 4.79 kilometers in the y direction, and that's going to be 6.19 kilometers in the x direction. But I'm not quite done with the problem yet. Essentially, what I have right here is I have my resultant in the x direction, and I have my resultant in the y direction. However, I'm looking for the magnitude. I'm looking for the length of that guy. So the way we get that, the magnitude of the resultant is going to be Pythagorean's theorem. So rx squared plus ry squared. Go ahead and I'll just write this guy out. So 6.19 squared plus 4.79 squared. And that's going to work out to be 7.8 kilometers. So that's the magnitude. Now the direction, so here we have the opposite side, here we have the adjacent side. So we'd say, okay, tangent of theta is going to be equal to opposite, the y, divided by the adjacent, divided by the x. Go ahead and you take the inverse tangent of that, and you're going to end up with 38 degrees north of east. And a little bit more playing around with vectors here. We have some vector A, and we know that it has some y component, and this is going to be the positive y direction, this is going to be the positive x direction. And I know that the y component for this vector is going to be positive 13 meters. And I also know that the vector itself is going to make an angle 32 degrees counterclockwise from the positive y-axis. So that's the positive y-axis, going to come over right here, make that angle 32 degrees. Essentially, kind of what I'm looking for is what is the x component of this. So that's going to be equal to ay. That's going to be equal to ax. And this is just a triangle. A little bit of SOHCAHTOA here. So here I have the angle. It's going to be the opposite side, and this is going to be the adjacent side. So I would say tangent of 32 is going to be equal to the opposite divided by the adjacent, just like that. And I know what ay is. I'm looking for ax, so I'd say ax is going to be equal to ay tangent of 32. So 13 tan 32. Go ahead and you type all that into your calculator, and you're going to say, okay, well, ax is going to be equal to 8.12 meters. And you might think to yourself, okay, I'm done. But let's just kind of think about this. We use trigonometry, but we have to use now our common sense. Here we have the positive x-axis. This is going to be the negative x-axis. Drawing a picture really helps here, because you can see that this point's in the negative direction, and that really, really matters. So it's actually going to be negative 8.12 meters. Now we're looking for the magnitude of A, so kind of this guy right here. Pythagorean's theorem simply says this is going to be ax squared plus ay squared. Go ahead, take the square root of negative 8.12 squared plus 13 squared. Go ahead and type that into your calculator, and we're going to end up with 15.3 meters.